To conclude, let's look back at all the steps we've gone through so far and get a basic understanding of the final step that's left in terms of building information to do a good and thorough job in the pre-design process. So we've taken physical attributes and made them virtual in terms of building context and site. We've tested a virtual object against physical data with simulation. We've made ourselves virtual by using VR, and now we want to take some of those virtual things and make them analog or physical objects again in this closing step. So we'll do that at 3 different scales with 3 different objects that we've used so far in the process. First of all, looking at the overall site that we've built, we can come into FormIt and simply go File, Export locally. And we're going to use the STL file, and I'm going to save all objects. So I'm saving this back underneath the name from this process, which was step 4 programming. I'll say save. Let's just replace that. And then I'm going to go into Cura. Most 3D printer software, the interface, the slicer that they use is fairly similar, and Cura is fairly universal, so that seems like the best one to use here. So we'll open up Cura, and I'm going to say load model, and let's grab that step 4 programming piece. So it shows up in place. And the first thing that I need to do is understand what scale I'm going to be printing at. We've done so much of this that we got sick of actually running the calculator over and over again. So we developed a small spreadsheet, simple little spreadsheet here. And basically it allows me to input a scale factor. So I know this is a large site. We want to print it roughly on a 12-inch by 12-inch printer bed. So I know a good scale for that's going to be about 200. So I know my scale factor that I need to use is 12.69%. So thinking of that as a percent, I'm going to be typing in as a scale factor in Cura 0.1, let's do 0.13, and that's going to get us right at that 1 to 200. So let's go back into Cura. I'm going to select my object, scale factor of 0.13. And that has that entire model, including my little programming pieces and even little indications of the structure directly on the build platform. Now, if you'll notice, I have set in the advanced a cutoff from the base. That's simply to thin this out and reduce the amount of time printing, and I think I can even cut a little bit more of that base off. Let's go ahead and drop that to about 10 millimeters. I don't want to make it too thin, but I also know that, yeah, that can shave a significant amount of time off. Let's give it just a little bit more thickness. The other things that I would note, and again, I'm not going to film the entire printing process. Just want to run through this so you can understand the settings and how to use the scale factor, how to import and how to use the scale factor. The other things that we can take a look at that can significantly improve speed are going to be the fill density. For most architectural things, we use about 5%. And the basic print settings. Typically in architecture, we're either printing with PLA or we are printing with a polyester. Both of them are low off-gassing and recycled. The PLA does a little better job in terms of not draping as much whenever there's an expanse, which we have often in architecture, window openings, door openings, things like that. The polyester is just super consistent and performs exactly the same way every time we print. And currently we're printing also with a Lulzbot TAS 6, which is an excellent little printer. So little printer, it's actually kind of beefy, which is one of the things that we like about it. So that's the overall site at 1 to 200. Let's go to another Cura file. And let's look at the more like the building scale, a 1 to 40 scale. So inside of FormIt, I can move to an individual building. So let's go into that instance and let's select just this building, and I will go File, Export locally. Again, I'm going to say STL, but this time selected only, and export. So this would be if I do a larger CNC cutout, or actually what we often do, if we get at that 1 to 40 scale, if we only have a variance of a 1/2 inch, on the topography at scale, our attitude is kind of why bother with it? Let's just print out the satellite photograph and place the models on it. It's much faster, it's much more effective, and we actually have much more data on that than we would CNC routing an entire site. So at that 1 to 40 scale, again, I'm going to call this step 9, 1830 block main. So let's save. And again, naming it with the street address really helps keep all these organized, because once you go into 3D printing, often you need to print these individual buildings one at a time. It's not any faster to group them all on the plate. It might be a little less labor in terms of starting and stopping the printer, but the print time will be exactly the same. And as I often tell our students with 3D printing, if I try and group 10 buildings on here, if one fails, typically they all fail. So one at a time is a pretty safe way to go about it. So let's go load model. I'm going to grab that 1830 block. All right, so we need to set the scale factor of 1 to 40 for this one. So I'm going to go back into my scale calculator, 1 to 40. So I need to reduce this down by 0.635. So I'm going to select my model, scale, 0.635. And now I've got that set and ready to go. But I've got one more thing. If you remember, a lot of these buildings, we dropped the base of the building by an additional 10 feet to make sure that they fully intersect with the topography inside of FormIt. Now, I didn't do that with all of them, but I did that with most of them. And I always brought it down a consistent number, 10 feet. And that's for a really simple reason. When I come into something like Cura, I want to be able to drop this model the exact same number each time. And 10 feet scaled down to millimeters, I believe, is right at 6.5. And so I can cut off that bottom 10 feet of the building to scale on every single building that I did that with, knowing then the building isn't going to be out of scale in terms of its height. So let's do one more of these, and let's look a little bit more at the overall building scale. Let's go to the last Cura file, and in some ways the more complicated one. So these are the individual groups that we built from Dynamo, and perhaps I want to print these things out at different scales. So this is still at that 1 to 40 scale, so that I can put them in the overall context model and see how they're going to perform. So again, when I brought them in, I need to scale them down by 0.63. I am kind of breaking my own rule here in terms of grouping multiples of them together, but should work just fine. Hopefully will work just fine. The TASVICE is an amazing machine. It'll work great. I have total faith. Now, there's a lot of overhangs in this particular model. So one of the other things that I will need to do because of this is definitely add supports everywhere. Now, this is going to add a little bit of time to the overall printing, but I know all of the overhangs and things that we should, that we'll typically get, will be able to print perfectly for me. And so you can see if I go to my layer mode, where all those overhangs are going to print, essentially all those supports are going to print. Now, if I had a little bit more advanced 3D printer, those might be water soluble, things like that. In this particular case, we'll simply spend a few minutes with the tweezers pulling things out, or in a lot of instances, as small as some of those pieces are going to be, just a couple of millimeters, a lot of times I'll just leave them in. I want them to print accurately. I want to be able to see volumetrically what's happening, but leaving the support material in, especially some of these that are going to be adjacent to an existing building, probably will be just fine. So that's going to get me an idea of how those print, and in 3 hours and 13 minutes, I can go through this process and have 4 different physical models to pop in and out of my larger context model to evaluate those different design ideas.